All right, these are logarithms, and these are all the formulas and equations you will need to get through this chapter. And it's a nice little cheat sheet. You can't use it on a test, but at least you have it there to help check. And there's space in here to fill other stuff in. But here's what we're doing. We're going over what a logarithm is. And this is just a basic intro into logarithms and to help you feel a little more comfortable with them. So what we're going to do first is change our exponential form into log, and then take the log form and change it into an exponential. So what we have here is base, exponent, and then the result. This is your base. The exponent is 4, and the result is 81. So you have a base, which is 3, an exponent, which is 4, and the result from that computation, which is 81. And so in exponent form, it's log of the base with the resultant. So it's log base 3 of 81 is equal to the exponent. Logs equal the exponent. So that's what a log is. It's like a question asking you what is the exponent. So on this one, this would be log base 2 of 32 equals 5. Okay? This would be log base 1/2 of 1/16 equals 4. So it's always log base equals exponent. So if you ever forget it, you don't have to think too much. Log is going to equal the exponent, and that's the base of the logarithm right here. It's right down here, so it's the same base. So write that one in log form. Pause and give it a shot. So you should have log base 3. It's going to equal 0, and that has to be the 1. So log base 3 of 1 is 0. All right, now let's try it in reverse. So for a logarithm, this is your base. The exponent equals 2, and the result is 9. So if we write this in exponential form, it's it's base 3 of 2 equals 9. So 3 squared equals 9. So write these in exponential form. And the way I like to think about it is you take the 3, you grab it, and then it's just like a little backwards. It even gives you the equal sign. It's 3 squared equals 9. So this is 3 to the power of 4 equals 81. This is 3 to the power of negative 2 equals 1/9. So try rewriting them. Pause and give them a shot. And that's what you should have. So it's 3 to the power of 4 equals 81. 3 to the power of negative 2 equals 1/9. It's kind of like a left, right, in. You have to work your way in. So it's 3 to the 2/3 equals that. That's it for logarithms. It's just rewriting them as an exponential. So when you see these logarithms, what they're asking is, what's the exponent? For a base of 5, what do you need to make 125? So for a base of 5, what's our exponent that'll give us 125? This is the result. And what they're asking for is the exponent. And it's 3. That's it. So log base 5 of 125 is 3. What exponent do you need to give to 3 to make 9? 2. What exponent do you need to give to 3 to make 27? Exactly 3. A little bit more tricky. Okay, so you know it's a 2 because it's 25, and it has to be negative. So that's all it is. 3 to what equals 9. This is 5 to what equals 125. So when you see a logarithm, it's just asking, what's the exponent? What's the exponent? That's all you're looking for. So if I have log base 2 of 4, what's the exponent for 2 to make 4? It's 2. That's it. So those are logarithms. They're asking what's the exponent. All right, so if you have two special ones that are used a lot, this is log of 2 and ln of 2. If you look at your calculator, scientific graphing, these two are buttons that are on there. And what log of 2 is log base 10. Same exact answer there. And ln would be natural log, and it's called log base e. And these are used a lot. Our number system is base 10, which is why we have a log of 10, and e is used a lot in applications. So that's why it has its own special button as well. So let's simplify these. This would be log base 10 of 100. So again, what's the question a logarithm's asking? What's the exponent? I'm going to put, that's a question. I'm not going to make an exclamation out of it. What's the exponent? So for a 10, what do you have to do to it to make 100? You square it. What do you have to do to that to make it into 1 over 10,000? Well, remember the fraction thing, you know it's negative, just like up here, negative 2. And then all you have to do is count the zeros. 1, 2, 3, 4. And that's it. Just like here, it's 2. Base 10s are nice, so negative 4 would give it to you. And if you don't, just use your calculator. So 100, and then you hit the log button. It's 2. And then same with the other one. 1 divided by 10,000. And then the log button, negative 4. So they're nice to check. That's why they're on the calculator. Same with the natural log. So this would be log base e. And the whole thing is to get used to writing this and knowing it. Log base e of e to the 5. So this one's a lot more obvious than you would think. For e, what's the exponent that would give us e to the 5? It's a nice comparison right there. Exactly, it's 5. So for this one, this is log base e of 1 over e to the 7. So if we rewrite it, it's log base e of e to the negative 7. So for a base of e, what's the exponent here? Negative 7. That's it. Okay? Now using your calculator, we're just going to calculate these and get some conclusions. So if you have 7, you want to use the natural log key right there. So it's 1.9. I'm going to round to 2. 1.95. If you have log of 5, you do 5 and then the log key. So 0.699. But now what if you have a 5? There is no log base 5 key here. So what we have to use is a change of base formula. And it's log of 7 over log of 5. Or you can use the natural log key of 7 over the natural log key of 5. You have to use the same one for each one. But you can think about it this way. 7's bigger. It kind of looks like it's on top, so it goes on top. 5's smaller, it goes on the bottom. It's not the reason, but it's a way to remember it. So we have 7 log divided by 5 log. My calculator, I have to enter it in backwards. Hit equals, and there you go. 1.2. Oops. 21. Now, if you're not getting these answers, make sure you close the parentheses. So when you hit the calculator key, it puts a parenthesis like this. Make sure you close it. So it should be log of 7 and log of 5, just like my calculator had. So but when I did it, it's 7 log. And see how it puts it in a parenthesis? Make sure you close it, and then it should give you the same answer. All right, so try it for that one. Log base 3 of 22. So you should have that, which gives us 2.81. And there it is. All right, here's some special ones. So enter these into your calculator. So we did I can't do that button. Negative 2, 2 negative, and then I hit the natural log button. And it says invalid input. You even heard the beep. It doesn't like it. This is not possible. It does not exist. How about 0 then? Let's try 0. 0. Okay. 0 log. Same thing. It doesn't like it. This does not exist. It's not possible. If you have a base of 10, there's no exponent that's going to give us 0. Even if you use 0, it gives you a 1, which is the next one. 1. Okay. 1 ln is 0. And 1 log is also 0. It's because anytime you get 0 for an exponent, you get 1. So if you have 10 to the 0, it's 1. E to the 0 is 1. So logarithms are asking, what's the exponent that gives you 1? So what's the exponent that'll give you 1? 0. So that's our rule. Anytime you have a log of 1, it's on our rule sheet right here, any base with a log of 1 will give us 0. And these are the things you want to think about. So logarithms cannot have negatives. So let's circle those in red. These are the bad. You cannot have negatives, you cannot have zeros in logarithms. And anytime you plug in a 1, you're going to get 0. And logarithms are asking, what's the exponent?